In this video, we're going to determine whether two functions are inverses using algebra. So the definition here is that two functions are inverses if f of g of x and g of f of x are both equal to x. So let's look at an example here where f of x is 4x and g of x is x divided by 4. So first we're going to find f of g of x. And remember from the last section that this means that we are going to plug the g function into the f function. We work from the inside out. So that means I'm going to take my f function, which is 4 times x, and replace that x with the entire g function, which is x divided by 4. So what we have is 4 times x divided by 4. We could also write that as 4x divided by 4. And what's going to happen with the 4's is that they're going to cancel out, and we're left with just x. Now for part B, we're going to do the same thing but in the other direction. We're going to plug f into g. So we're going to have g of f of x. G is x divided by 4, and we're going to replace that x with the f function, which is 4x. So 4x divided by 4. And again, when we have 4x divided by 4, the 4's are going to cancel out, and we're left with just x. So, since f of g of x is equal to x, g of f of x is equal to x, that means that yes, they are inverses. All right, for number 9, we're going to look at another example. So the first one that we're going to do is f of g of x. I'm going to give myself a little bit more space here to write. So f of g of x means that we're plugging g into f. So we're going to have 5 times, and then replace this x with x plus 5 over 9. So this is being plugged in here. And then we have a minus 9. Now, here we have a 5 and a 9. Those aren't exactly going to cancel out. We have a little bit more work to do here. So I'm going to put the 5 in the top of the fraction like I did before. It's going to be multiplied by x plus 5. So I'm writing it in parentheses like that so that I know that everything is multiplied by 5. 5 times x plus 5, when I distribute that out, I get 5x plus 25. And then don't forget this minus 9. Now, to combine everything into one fraction, which is what you're going to need to do in the Check Your Understanding in order to get it correct, I need a common denominator. So I need a denominator of 9 for this 9. So I need to multiply both the top and bottom by 9 in order to get that. So we have 5x plus 25 over 9 minus 81 over 9 and now when I have a common denominator I can combine. So 5x plus 25 minus 81 over 9. As you can see, this one, things aren't canceling out nicely, and I'm not just going to end up with x. But in the Check Your Understanding, you're still going to need to figure out what it is. Even though I can already answer the question of are f and g inverses, the answer would be no. So 25 minus 81, that is going to be minus 56 over 9. Now we're going to find g of f of x. So we're going to plug in the opposite direction. Fortunately, this one is a little bit easier. So let me switch to a different color here. So I'm going to plug this 5x minus 9 in for x into the g function. So it's going to go in for that x in the numerator of the fraction. So g of f of x equals, and we're going to have 5x minus 9 and then plus 5 over 9. Now I put this in parentheses, but I actually don't need them because I'm not multiplying it by anything or squaring it or anything like that. So 5x minus 9 plus 5 is what I have in the numerator, and that is divided by 9. 5x minus 9 plus 5 is 5x minus 4, and then divide by 9. So the answer to our f and g inverses is no, because they both don't equal x, they equal something different.